Hi, this is Ashley from Period 4, and this video is about Unit I, Concept 2, where I'll be showing you how to graph logarithmic functions. And sorry if I'm talking weird, I don't know if I am, but I just got my braces tightened, so bear with me. So I want to write, it says key points right here, but I'm going to start on asymptote first because it is the easiest once you see your equation. So our equation is this: log base 7 x plus 3 minus 1, and our asymptote is x equals h, and this is the skeleton, I like to call it, equation where we plug in all of our numbers and variables. And as you can tell, h, it's minus h, but we have a plus 3 here, so that means our h must be a negative. So our h is negative 3, so our asymptote is x equals negative 3. Moving on, see, we're already done with that. So x-intercept, all you do, like a regular graph, is set your whole graph equal to 0. So I add 1 to both sides, and from this point we're going to exponentiate, which we know from unit H, and I exponentiate it for the 7, so this cancels out, and 7 to the first power is 7. So 7 equals x plus 3. I subtract 3 from both sides, and I get x equals 4. And so our x value is 4, and we set y equal to 0, so that means our x-intercept is 4, 0. And we're going to do the sort of the same thing for y-intercept, except now we plug in 0 into our x part, like we have up here. So we have log base 7 of 0 plus 3 minus 1, and that just simplifies to this. Just plug this into the calculator, and remember, do change of base formula, so it should be looking like this. You should be plugging that into your calculator, or you can do natural log. I just like to do log base 10, so, and then I get 0.565 minus 1, and I get this. So we plugged in 0 for our x value, so it's 0, and then it equals negative 0.435. And then now I look at my domain, and okay, so because this is a logarithmic function, our range is always going to be infinite because this is our asymptote, and range, our function, extends on and on and on, up and down, so that means there's no restriction. But domain, you see from left to right, we have a restriction because of our asymptote. So that means from negative 3 to all the positive values beyond that, our graph continues there. And that's true, you can see right here. It doesn't go over here because of our asymptote. Oops, sorry, that's a text message. And for here, I just found a few points, and you want to like think about them, plug them into your calculator first. I don't have my calculator to show you, I don't know where it is right now, but just to make sure. Okay, wait, let me write this out for you. Okay, so you want to plug this into the calculator because you can't plug this into the calculator. We have to do change of base formula again. So we're going to do ln x plus 3, and then divide it, because we're doing change of base formula. ln, I'm doing ln for you guys this time. And then we basically have that. So this is basically just this, but change of base formula. Minus 1, plug that into your y table, and then enter that and press for the table to see all the points. And then you can look at any of these points. I picked negative 2, negative 1, 1, and 2 because they're just on the, because I have a 4 already, so I know I didn't want a 4. I don't want to plug 4 in because it's like pointless. And then I'm not going to plug in 0 because I already have in 0. So you just want to pick any of them that are obviously on the right of the asymptote, because all your graphs are always going to be on the right. So negative 2 is to the right, negative 1, 1, 2. Just plug that in. I got these numbers. And from there, all you need to do is plot them. Sorry, I'm sick too. Everything's wrong with me. And then you just connect them like any other regular function. And this is your logarithmic equation. I hope you learned something from this. Thank you for watching.